Welcome to this explainer. Okay, today is a pretty huge day in our computer science journey. If you're a 7th grader, or honestly, just anyone stepping into the world of text-based coding for the absolute first time, this is totally for you. We're officially leaving behind those drag-and-drop blocks and stepping up to typing real, actual code. And yeah, I know, staring at a blank screen waiting for you to type can feel a little intimidating at first, but I promise it is an incredibly empowering new tool. And by the end of this explainer, you're going to see that you already know the big ideas. We're just learning a brand new way to express them.
Here is our roadmap for today. First up, we'll cover the basics of sequencing. Second, from blocks to text. Third, inputs, outputs, and variables. Fourth, data types and operators. And finally, testing and debugging.
All right, let's dive right into Section 1, Sequencing Basics. It's all about planning before coding.
So let's start with the absolute core of computer science, which is actually super simple. A sequence is really just the specific order in which instructions are carried out. Think of it kind of like baking a cake, right? You literally cannot put the batter in the oven before you crack the eggs. Well, computers are exactly the same way. They will do exactly what you tell them to do, but in the exact order you tell them to do it. Practically everything we're doing today basically boils down to getting our sequence right.
Now, once you've got your sequence dialed in, guess what? You've got yourself an algorithm. An algorithm is just a sequence of steps or instructions used to solve a problem. That's the whole shebang. It sounds like this really fancy, complex academic word, but honestly, if you've ever drawn out a quick flowchart to make a decision or jotted down a step-by-step guide for a friend, you've already created an algorithm. It's just your systematic plan of attack.
Okay, so you're building algorithms, but you want to get fast and efficient at it, right? That brings us to pattern recognition. This just means looking for a pattern and using it to solve your problem. By spotting things that repeat, you can actually reuse chunks of code and predict upcoming steps rather than writing out every single tiny detail from scratch every single time. It is, without a doubt, the ultimate time saver for a programmer.
Moving smoothly onto Section 2, blocks to text. We are officially upgrading our toolkit.
So, let's do a quick comparison here. On one side, we have block-based coding, like Scratch. You know the drill. You drag and drop these ready-made blocks that click together like Lego bricks. You never really have to remember the exact code. But on the other side, we've got text-based coding, specifically Python. Now here, you type every single instruction yourself, which means you do have to remember the correct syntax, the grammar of the code. But here is the absolutely crucial point. The big ideas, like sequencing, making selections, using variables, they are exactly the same in both. Text-based is just way more powerful and gives you a lot more flexibility. Actually, scratch that. Quick fun detour while we're on the subject of Python. Did you know it wasn't actually named after the giant snake? No way. The creator of Python was just reading scripts from the classic British comedy series Monty Python's Flying Circus while he was developing the language. So basically, whenever you code in Python, you're participating in a little bit of classic comedy history. How cool is that?
All right, back to business. Section 3, inputs, outputs, and variables. Let's look at data flow in Python.
So how does information actually move around in our programs? Let's map it out. First, we have the input. This is the data the user types in, which we grab using the input command. But that data needs a place to live, right? So we send it over to a variable. Think of a variable as a labeled box that stores a specific value while your program is running. And then finally, we have the output. This is what the program spits back out onto the screen for the user to see using the print command. It goes input, into the variable box, and out as output. Now, when we're actually typing our outputs in Python, we have to be super careful with our formatting. There's a major rule here. Text inside speech marks is printed exactly as written. If you type print, quote, hello, unquote, the screen will just literally say hello. However, a word with 0 speech marks around it, that tells Python to go look inside that labeled variable box and print whatever is currently stored inside it. If you forget your speech marks, Python's going to go wandering around looking for a variable that might not even exist, and your program will crash.
Which leads us to Section 4, data types and operators. Time to handle some information.
So what kind of data can we actually stuff into our variable boxes? Well, at this stage, we're mainly using 3 basic data types. First up is the integer, which is just a whole number, like 8 or -3. Second is the real number. Some people call it a float, which is a number with a decimal point, like 3.5. And third is the string, which is simply text inside speech marks, like a name or a city. Now, once we have our numbers stored securely as integers or real numbers, we can use the 4 arithmetic operators to do some math. A plus sign to add, a minus sign to subtract, an asterisk to multiply, and a / to divide.
And you really got to watch out for this one. This is a classic beginner trap. The input command always, and I mean always, gives back a string. Even if the user types the number 5, Python looks at it and just sees the text character 5, not the actual math number 5. So if you want to do math with a number someone typed in, you absolutely must change it to an integer first. You do that by wrapping it up in the int command. Because if you try to multiply two strings together, well, Python's going to get real confused real fast.
Okay, let's put this to the test and see how it all builds together. Take a look at this quick little Python program. We have x equals int, parentheses, quote 12, quote parentheses, y equals int, parentheses, quote 3, quote parentheses, result equals x divided by y, and finally print, quote, answer, unquote, followed by our result variable. What do you think this is going to output on the screen? Take a second.
Got a guess? Well, here is the answer. The program prints answer 4.0. See, because we used that int command, x safely stored the actual integer 12, and y stored the integer 3. And 12 divided by 3 is 4. But hey, notice that 0.0? In Python, using that division operator always gives you back a real number with a decimal, just in case there happens to be a remainder.
Almost at the finish line. Section 5, testing and debugging. Let's talk about fixing our inevitable mistakes. Look, nobody writes perfect code the first time. It just doesn't happen. To know if our code is actually working, we need a test plan. This is just a structured set of tests where you jot down the data you're going to enter and the exact outcomes you expect to see on the other side. It gives you a nice, safe baseline. If your expected outcome doesn't match what actually happens when you run the code, boom, you know you have an error to track down. And when that happens, we enter the debugging phase. Here are the steps to debug like a pro. Step 1, and don't skip this, always compare the broken program back to your original flowchart. Sometimes the code you typed is perfectly fine, but your initial algorithm plan was just wrong. Step 2, figure out what kind of error it is. A syntax error means you made a typing mistake, like forgetting a bracket or a speech mark. A logic error means the code runs fine, but it does the wrong math or gives the wrong answer. Once you know what you're dealing with, step 3 is to systematically remove those errors. You know, one of the best ways to test your ideas safely before you go writing some massive, complicated program is to build a prototype. A prototype is just an early, super basic version of a product built specifically to test an idea and gather some feedback. It's totally like those little cardboard model houses an architect builds before anyone pours the real concrete. In coding, we build these quick, kind of throwaway prototypes just to make sure our sequence and our algorithms actually make sense before we spend hours making the code look perfect.
So, that leads us to our final thought for this explainer. Think about the code in your day-to-day apps and the games you play. How might you use pattern recognition to plan and build your very first text-based prototype? You've got the toolkit now. Inputs, variables, operators, and the pure power of Python text. The next step is literally just spotting a pattern, planning your algorithm, and typing that very first line. You've got this. Get out there and start building.